All right, how are we doing today? I'm here someplace. How are we doing today? This has been the craziest video that I've ever attempted to film. I've literally had more stuff go wrong than go right. I'm on day 2. It's like 4 o'clock in the afternoon. I swear I just started filming this. It was like 2:20 something, and now I'm starting over again. What I've got basically is I've got a machine set up for short arc. I'm going to flip this camera around. I've got my Lincoln SP 135T. Okay, now the T is for tap, and basically that means that the voltage setting is either A, B, C, D. So low, medium, high, and supersized, I guess. Wire speed is infinitely adjustable. I started filming this yesterday with this machine, and I've got some issues. Something's wrong with the liner. I can feel it up in the neck as I'm welding, and it never really did run smoothly. So I've gone ahead and I've taken the old Miller-Matic 252. Not old, but it's a few years old here at the school, and I've got this thing set up. Now right now I've got 19.4 volts on it. That's the voltage I had basically when that Lincoln was maxed out. I played with that yesterday, and maybe I'll include some of that footage so I don't feel like I completely wasted my time. And currently I've got 200 inches per minute of wire feed on it. That is not enough wire speed, but we're going to start off by kind of tuning this in. So I'm running 023 wire. It's really my preferred wire for short circuit transfer in most cases. 023 drive rolls, and then down at the other end here we have a Tweco 220 little fusion MIG gun, and this runs pretty good. It's 10 feet long. We actually shortened it so that it would work well. That MIG gun was originally 15 feet long, and it works awesome with 030, 035 wire, but the 023 it just didn't feed well, so we shortened one of them for here in the shop. The Lincoln is my own personal machine, and it's old. I bought it in 2002 after a skills competition. I was a judge that year up in Bangor, Maine, and they were running these little Lincolns for some short arc, and I thought, well, that's a pretty neat little machine. And I think I paid like $400 for it at Matheson at the time, and it's probably done more personal work for me than all the rest of my equipment combined. And I've got a lot of equipment. I've got almost the same stuff we have here at the school. But I don't weld heavy structure at home. A lot of times it's small stuff. And it is an awesome machine. It's too bad that it's not running today. But what I want to show you is the tune-in procedure for short arc, and we're going to do a little bit of welding with this. Now, I'm going to limit the output of, find this on the camera down here, I'm going to limit the output of the Miller-Matic to the range that the Lincoln could run. A lot of people that might be running short arc are going to be running on a machine like this that is this plugged into a 110 outlet. So you will get more power out of a modern inverter machine. You go buy a brand new machine that's an inverter light machine, you're going to get more horsepower. Next door in automotive, they have a brand new Miller. I don't remember the model, but it's a 120 volt machine, and I swear it squeezes every ounce of available power out of that wall outlet, and it runs amazing. But I'm just going to run with what I've got here in the shop today. But 19.4 volts is where this is set. That's where that one maxed out. The lowest setting, voltage setting, again, there's 4 taps, there's 4 settings, was 15 volts approximately. And the 2 in the middle are obviously in the middle. I don't know where they are, but for all practical intents and purposes, that doesn't matter. It has intermediate adjustment. So we're going to play with that. We're going to set up, and we are going to show you what short arc is like. We being me, I guess, because I'm solo here. The wire feed speed I'm starting with is 200 inches per minute. Now, wire feed speed is important because it gives you a fixed adjustment that is not going to vary based upon voltage loss or cables or anything like that. So let's go over that and then we'll strike an arc. All right, I'm going to trip over stuff here. I try to preach wire feed speed here in the shop. You know, some booths are directly across from the power supply rack and some are, 30, 40 feet away. So the length of cabling that runs from one booth to another varies a lot. So a voltage setting that works perfectly good in booth 9 might not work in booth 1. In booth 1 might have to be, hotter. Wire feed speed fixes all that, okay? Now, not that that's an important thing for a little 110 machine that you have at home, but again, when you're setting up a piece of equipment like this right here, I can turn this machine on with any given wire diameter, and I can preset the wire speed and the voltage and know that I'm going to be right in the ballpark, if not perfectly tuned in, because I've just kind of memorized those settings. And I'm not talking about setting the knob on 4. I'm talking about an actual speed in inches per minute. So to set your wire speed, if you're interested in kind of playing along here, you're going to take your MIG gun, you're going to pull your trigger, and you're going to time it for 6 seconds. I'm going to count down. I'm going to go 3, 2, 1, pull. 1, 2, 3, 4, 5, release. Okay. So there's 6 seconds. Then I'll measure that wire that's come out of the gun. Wire feed speed. And I have a tape measure that just broke. So, Six seconds is 1/10 of a minute. So if you get, 20 inches of wire in 6 seconds, that would be 200 inches of wire per minute, okay? So right now, that's what I have on this machine is 200 inches per minute. So if I pulled the trigger for 6 seconds, I would have 20 inches of wire coming out of that gun. That is a helpful thing to get accustomed to memorize, especially if you're changing wire diameters or if you're working with a machine like in a production environment where you're not always, in this case I have a 10-foot MIG gun. I'll never be more than 10 feet from the power supply because I can't be, right? It's a wire feeder power supply single unit. But every other machine that's in here is hooked to a harness. That harness is, in the booths, they vary in length. If they're out on the floor, the shortest harness is 50 feet. And if we're working on a remote job or simulating a remote job, they could be 150 feet away from the power supply, in which case, again, they're going to have voltage loss. But the wire feed speed is the same. So by presetting your wire speed, and initially you would just tune your machine in to where it's running right, and then you would just kind of measure your wire speed and kind of drop that down, even if it's just mentally. But anyway, moving on. Right now we're going to look at tuning in this machine. I've got 19.4 volts. Again, that's the top end of what this machine would put out, which I'm going to guess is reasonably typical of most wall outlet type machines. I do not have enough wire speed. I know that. I'm at 155 now. Okay. And that is really, you can hear it. That is definitely not good, okay? That's not what we want. So we're back at 200 for reference. I'm going to jump it up to 250. Now really listen as much as you're watching because the sound is important. So here's 250. Now that's probably usable to some extent, depending upon what you're welding. But again, right now I'm at 300. Let's listen to that. So there's 300 inches per minute. Let's go to 350. So that's the sound that I'm really looking for. Now, depending upon what you're welding, you may need a little bit longer arc. You may need that extra, the voltage to wire ratio. But again, we really want to have that progression, okay, of not enough wire, spit, 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 up to that constant buzz as you're tuning your machine in. Once you get that tuned in, you're basically ready to rock and roll. And you can fine tune that depending upon what you're doing. You may find that if you've got thicker material, you need to drop that down so there's a little more voltage to help melt. And if you have thinner material, you may find that you may even tune that up just a little bit. So you can travel faster if you've got a gap or something like that. This particular machine has a chart inside of it, and it lists, it doesn't give a wire feed speed, but it basically lists 14 gauge as the maximum thickness material to weld on with 025. It actually lists 025 wire. 023 obviously is a little bit smaller. It doesn't sound much smaller, but in terms of cross-sectional area, that 0.02 of an inch difference means 18% more cross-sectional area, which means that the same wire feed speed, it's 18% more wire going in. So sometimes a little bit does make a lot. Now that we've got that tuned in, let's do some welding. I'm going to run some beads on this plate as it's set at the 19.4 volt setting. The 0.4 is not important, guys. It's just where it stopped. 19 and a half. It's going to be imperceivably different on this thickness material. But I'll run some single light fillets, maybe do some outside corners, just kind of see what this looks like, all in the downhand or horizontal flat position, and then we'll move on from there. And this is so small, push-pull doesn't make all that much difference. So it's running smoothly, it's basically tuned in, so let's go ahead and tack something up and try to make something that's pretty. We'll get rid of this piece of scrap. So again, there's a little short arc bead. I'm going to zoom out here just a whisker. Whoops, wrong way. And again, this is just a really thin little 14 gauge plate. Not much to it. Let me tack up a outside corner joint. Outside corner joint. Okay, so that's really hot on this. That is, again, the outside corner. That's what it looks like. And I'm zoomed in close. And at that setting, we melted completely through on the inside. Okay, so that is, again, a lot of power really on material this thin. So the next step is going to be, let's take and tune this machine down, and I'm going to go to the low end of what the old Lincoln would put out. And again, that was 15 volts and 130 inches per minute. So I'm going to drop it right there. At that setting, you know, travel speed is really important. It's very, very easy to get slightly ahead of the puddle. But again, we have a plate here that's welded, and let me flip this over. So there's our, let me zoom back a little bit. There's our outside corner. Again, it really is not quite hot enough, I don't think, although we did melt through on the inside. If I can get a grip on this. We did melt through on the inside, but again, I personally like the melt through I had at higher voltage better. But the point being is, it doesn't really matter where you're tuned in, what the thickness of material is. That constant crackle is what you're looking for. So again, start low with the wire speed and turn it up. Or if you preset your wire speed, start a little hot with the voltage and turn it down, and you'll get the same effect. Let's go ahead and set this up on some verticals. I'm going to go back to my previous setting. We'll show you some vertical down, and then we'll look at fillet welds on some heavier material at that same setting, just so it's nice and slow and methodical, and maybe we can get some good arc shots. All right, let's hopefully I can get the arc started without knocking the plate over, because it's not really grounded well. Vertical down. Pretty quick, honestly. That's the way to do outside corners. There that is. Let me again zoom out, and we'll get another look at this. I did get melt through on the inside, even on that down bead, which is perfect. And I got a good looking bead profile on the outside. So that is vertical down. Now let's do vertical down in a T-joint. I've got a nice T-joint right here tacked up. Make sure the camera's in focus. Appears to be. I'll zoom in. And that's a good looking weld right there. So T-joint, vertical down, 350 inches per minute, 023 wire. And if I haven't mentioned it before, C25 gas, 7525 argon CO2. At the shipyard, I know at EBMF, where they do the prefab on, you know, pipe and vent and stuff, they run straight CO2 with their short arc on galvanized vent. So it's another option. Right now I'm running C25 gas because that's what I run with my flux core, and it gets the job done. Okay. Went right my own way. That was fun. I can't really see past the corner. The camera's in the way. That little spit it did at the beginning, that's basically because we have a bad ground. Every time I move this plate, I kind of reestablish the ground. If that happens, just let go of the trigger. It'll have stuck. The plate will have bonded to the bench in this case, and then pull the trigger again, she'll start right back up. But again, I've got a vertical down bead right there. Again, good looking weld. I've got some on the back side here. Let me grab my flashlight. Again, I actually got, if I can get this synchronized, I actually got there we go, we're in focus. Tiny amount of melt through, so even at that speed, we're getting good penetration. That really, in a nutshell, guys, is the basics, you know, sheet metal, mostly vertical down, horizontal or flat work. So I'm going to go ahead, I'm going to tune this down a little bit more, We're going to do a couple of butt welds. I'll set up these plates both with a slight gap, and maybe I'll set up one that's tight. We'll try to do that, and then we'll play with some thicker material and see what we can do. All right, so I've got a little, I feel like I'm on something. Good gravy. I got a little butt weld here. Again, this is 14 gauge, it's butted up tight. I'm just going to weld the last little bit of this, whatever I feel I can reach without hitting the camera, and we'll see what kind of penetration we get. Again, we're at 19.5 volts, 350 inches per minute, and your homeowner 110 machine should be perfectly capable of running those parameters. If I can do this without hitting the camera. Close. So there's a pass on that. Let's see if we can get full penetration. I guess no problemo, right? So again, we can get full penetration through that from one side on 14 gauge with that homeowner machine. Ugh, good gravy. I'm telling you, it's one thing after another. All right, I don't actually have high expectations that this is going to be successful at this setting, but just why not? I'm going to try this at the setting I have now. Let's see what we can do vertical down on this, and if we can do anything with it at all. If I have to stop and go squirt, 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 I know I could do that all the way down the plate. Anybody could, but we're going to call that not working. Okay, we'll tune the machine in for it. I'm going to stop right there. Now that is welding. You can see that I've got a bead on there. If I find the spot at which this is focused, somewhere is in the neighborhood here. Between that and my glasses, it's hard to tell. So that's welding. I'm going to turn this around, and again, we are melted through. But again, it's a little out of control. Okay. So I'm going to go ahead. I'm going to turn this around. In fact, actually, I'll leave it where it is, and we'll tune this in. Kind of together. I'll readjust the camera. So what I've done is I've dropped this to 17 volts. That might be equivalent to like a B or a C setting on my other machine. Remember the low end was 15, 17. It's only talking 4 volts difference, so we're about halfway down. 250 inches per minute wire speed. I'm just going to tune it in on this T-joint. Until I get a crackle. When I get the crackle I want, we're going for it. Okay. Looks like we're there. I've got a pretty steady crackle. That was a complete wild guess on the wire speed, but an educated guess, I suppose. So let's try that on this joint right here. See if it's a little more controllable. Of course, we have a bad ground when I first get started. So again, there's a bead there. We melted through on the back side. It still works. I'm going to start up at the top again and work my way down. We'll reset this real quick. We'll try this one more time. It's still a little bit hot. I mean, it's working. It would work. I'm going to drop it down to another volt, and I'm going to go down to 200 inches per minute. We'll see what we get. All right, we're going to try again 16 volts, 200 inches per minute. Again, we're really just looking for a good, steady adjustment. I can tell you on the newer machines, at least the Miller next door, there was a setting. It's an 023 setting, and basically you just set it on that setting and you just adjust wire speed. The machine automatically tunes the voltage in for you. You don't have to think about it. and it's friggin' perfect every time. So, you know, technology has definitely improved since these machines were built. Murphy's in the house. Try this one more time. That's actually not that bad. I can't really see. I'm a little bit out of view personally. I think it needs a whisker more wire speed. I had to have the gun in real close before it started to weld smooth. I see my battery's about to die, so I'm going to plug my camera in. I just need one more thing to go wrong on a 2-day short arc video. All right. From here, what I'm going to do is I'm going to tune this machine in for vertical up. So there's the back side of what we just welded right here. Front side, again, right here. Constant crackle. Let's reset and let's go vertical up. And again, initially I'm just going to tune in on my thin material, and we're going to weld. I'm going to weld right where it's set, 16 and 200, and we'll work up from there. At the high end, we'll go up to again 19 and a half and 350, and we'll try welding on some thicker material and 1/4 inch thick material, at least on the edge, and maybe we'll do a quick impromptu brake test. And I'm going to try to weld uphill with it right where it's set right now. Let's see if I can't figure out that's the lowest I can go. Try right there. So it's actually running pretty good. My hand is getting caught on my camera setup. Let's take a look at this little bead. You know, it's running good. I can't see past this thing I've got up on top of my camera and everything else, but you know, we're getting a decent bead. For sheet metal, this would be just fine. I'm going to go ahead and I'm going to tune this up another volt. I'm going to go to 17 and 250. We'll just see this hotter and hotter. 17 volts, 250 inches per minute. Get it ground. There we go. So there that is 17 volts, 250 inches per minute. And again, it's starting to hump up on me. I'm not getting let me get this in focus right there. It's starting to get a little bit humped up. I'm going to try to back this around, and I'm going to do a weave pattern. Hopefully the camera is looking over the wire enough, you can see. But here's a weave. That looks really funky. Again, you'd never ever need to do that in the real world, but just so you get a chance to look at that puddle. All right, what I've got here is I got 2 1/4 inch plates welded together. These are a couple of practice plates that I grabbed out of the scrap bin. And I've got the outside corner tacked up. I got a little bit of a gap in there. I'm going to go ahead and just weld this up, vertical up, give you an idea for what this looks like. We should see some penetration probably through the back side. I wouldn't typically weld material this thick with a small machine like that. I do have the Millermatic at 19.4 volts, 351 inches per minute wire feed speed. So it's really simulating the absolute maximum that you're going to get out of one of these small home, wall plug-in machines. But we'll kind of take a look at this, and then, as I mentioned earlier, I think, depends on how the editing goes, I'll show you a challenge box that I'll have for the students that they weld up with this process. Let's go ahead and see what we can do. If I get out of my own way. Hey, I guessed. I'm right at the top of the camera. All right, this is really the limit of what you could do with a small machine. There's the bead that we have right there. Again, nice looking little bead right there. Vertical up, MIG, and we actually have, if I can get this on camera, we actually have some penetration through to the back side. Now the sample that I did yesterday, I broke, and I might have deleted that video. Let me just dig it up here real quick. So this is one I did yesterday, and again, this was an outside corner weld, and you can see, hopefully if this stays in focus, that we did get good penetration in here. There's either another video on the channel that I did a few years ago on fillet break tests, or I'll do one. I'll take a look and show you kind of what you're looking for. But at any rate, that's short arc, okay? Vertical up welding is something I'll talk about more specifically in another video when I introduce pulse arc. I've gone over it with a bunch of the students, but I haven't done it formally with the class yet. It kind of really is more of a BIW thing, and some students do it, some students don't. But that in a nutshell is short arc. I want to grab that sample plate though, show you that real quick. So this right here I just called the inside out box. This is a box that is cut out on the CNC. The students have to assemble it. And this is welded up with short arc. Now this was a sample that I welded up, and this was all welded with the old Lincoln machine just a month or so ago. But if you take a look at this, if I orientate this correctly, probably not. Anyway, every weld on this was welded vertical up. So this entire box was welded vertical up. So it wasn't welded in position, in overhead and everything else. It was welded vertical up. And the reason for that is it's 3/16 of an inch thick. So this one really would not be suited to welding any other position except vertical up with the little machine, because it's basically just out of power. So that machine was wide open, maxed out, and again, it was completely welded in the vertical up position. So the welds are solid. I mean, there was melt through on the inside. Penetration was good. And again, that was done with a homeowner machine that plugs into a wall outlet, okay? So that's a look at short arc. Hopefully I covered everything. God, I've been filming for like 2 days. It's gonna take me twice as long to edit this as it did to weld it, and hopefully it's gonna end up being short. I think I'm going home.